Let's find all the zeros of w of x, and then we're going to write it in factored form, and then we're going to sketch the graph after. So we notice that the degree is 3, therefore we know that there should be 3 zeros. And if we examine the sign changes, the first term is negative, second term is negative, the third term is positive, and the last term is positive. So now 1, 2, 3, 4. So we have 4 terms, you have 4 signs. So from negative to negative, there's no change. Negative to positive, there's a sign change. So that's our first sign change. Then positive to positive, it didn't change. So there's only one sign change. Therefore, these 3 zeros that we're looking for, we should know that one of them should be positive and 2 must be negative. Okay, so now to find these 3 zeros where we have 1 positive and 2 negatives, we need to generate a list of possible zeros. So we'll put here possible zeros. Let me write it here. So these are the possible rational zeros. We are going to consider positive and negative of some numbers. Now to determine this list, we are going to need the constant term and the leading coefficient. So we'll take the constant term, which is 30, and list all the factors of 30. So factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. And then we will take the leading coefficient, which is 3. We will ignore the sign, negative. We'll just take 3. And we get the factors of 3. And that's going to be 1 and 3. Then we will divide the factors of 30 by the factors of 3. So we'll go 1 divided by 1, that is 1. 2 divided by 1 is 2. And so all of this, when divided by 1, will give you the same thing as this numerator here. So we'll just list all of those integers. These are called integers. So 3, 5, 6, 10, 15, and 30. So now we're done dividing the factors of 30 by 1. We now will divide these factors by 3. And so we'll have here 1 divided by 3. Well, that's going to give us 1/3. And then 2 divided by 3. That's going to give us 2/3. And then 3 divided by 3 is 1. We already have it. 5 divided by 3, we don't have it yet. So we're going to include that in our list. 5/3. And then 6 over 3 is 2. We already have it. 10 over 3, we don't have it yet. So we're going to put here 10/3. 10 over 3. Then 10 over 3, 15 over 3 is 5. We already have it. And 30 over 3 is 10, and we already have it. So now we're going to close our list. These numbers are the possible zeros. So these 3 zeros that we need to look for, where 1 is positive and 2 are negative, all of them could possibly be in this list. Okay, so now let's erase this. So now that we know how many zeros we're looking for, we know how many should be positive and how many should be negative, and we have a list of where to find those zeros, then we start the search for the zeros. So to search for the zeros, we are going to need the coefficients of w of x. So we start with -3, then -12, and then +21, and then +30. Notice that the exponents are 3, 2, 1, 0. So no exponent is missing. So we just copy down -3, -12, +21, and +30. All right, so we're going to start off with 1 because we don't know which ones of these are zeros. So start off with 1. See if it's going to work. So we'll put here -3. Okay, so we bring down -3. -3 times 1 is -3. And -12 minus 3 is -15. -15 times 1 is equal to -15. 21 plus -15 is 6. And 6 times 1 is 6. Now we know that this is not 0, it's going to be 36. So what this is telling us is that W of 1 is equal to 36. So therefore, 1 is not a 0 of W of x. So we're going to try another number. So 1 does not work. If 1 doesn't work, then we are going to try -1. So we bring down -3. We multiply by -1 and we get +3. -12 plus 3 is -9. -9 times 1 is +9. 21 plus 9 is 30. And 30 times -1 is -30. So now we have opposites. Therefore, when we add them, we get a 0. So now we found 1 0 of W of x. So -1 is a 0 of W of x. So this one, we can write this down as W of -1 is equal to 0. So we say that -1 is a 0 of W of x. Okay, so now we need to find 2 more. So 1 more negative, and then the other one should be positive. So we're just going to ignore this. Okay, and then, so we're done trying 1 and positive, 1 and -1. This time, let's try 2. If that doesn't work, we're going to try -2. So let's write 2. So now we bring down -3. We multiply and we get -6. -6 and -9 gives us -15. -15 times 2 is equal to -30. And we have another opposites. So we'll get another 0. Okay, so that means we found 2 zeros already. The zeros are -1 and 2. Okay, last 0 to find. Now, if we have only three terms left, three numbers left, 1, 2, 3, and the last one is 0, this is a linear factor of w of x. These represents the coefficients of a linear factor of w of x. So that linear factor is negative 3x minus 15, and then we equate that to 0 because we're looking for the 0 of the function. So now this will become so we want to isolate the negative 3x by adding 15 to both sides. Therefore, negative 3x is equal to 15. We divide both sides by negative 3. Therefore, x equals negative 5. This is the third 0. So the zeros are negative 1, 2, and negative 5. So now we can write w of x in factored form. So in factored form, it's going to be parentheses x minus the zeros. So x minus negative 1 times x minus the second 0 is 2. So x minus 2. And the third 0 we found is x minus negative 5. And we are going to copy this leading coefficient. It's going to be placed here in the front. It's negative. So, simplifying this, we will get a w of x is equal to negative 3 times x plus 1. Oh, why did I put a 3 there? Times x plus 1 times x minus 2 times x plus 5. Okay, so now we want to sketch the graph. So to sketch the graph, let us get the x-axis. Draw the x-axis. Okay, here's the x-axis and the y-axis. Let's do that. Let's put the y-axis too. Okay. So okay, so let's put the zeros of the function on the x-axis. So again, the zeros go in the x-axis. So zeros are negative 1, 2, and negative 5. Now we want to also find the y-intercept. And the y-intercept is w of 0. So y-intercept is equal to w of 0. So we are going to plug in 0 to the x. So we want x to be 0. So x to the third becomes 0 to the third. And 0 to the third is 0 times negative 3 is 0. So this thing becomes 0 if x is 0. Now x squared, so this becomes 0 squared. 0 squared times negative 12 is 0. So this term becomes 0 also when x is 0. And here 21 times 0 becomes 0. Therefore, the y-intercept is 0 plus 0 plus 0 plus 30, which gives us 30. So the y-intercept is 30. Okay, so the y-intercept is 30, and so where are we going to put 30? So this is 50. So maybe 1, 2, 3, 4, 5. So maybe 1, 2, 3. Maybe 30 is going to be probably here. Okay, so now these are the important points in the graph. So when we sketch, we know that we have to touch the y-intercept. Usually we'll find out where it starts, but how does it behave right here on the left side of -5. We can also start here. So we know it's going to go through the y-intercept, so it has to come down for this, and it has to touch this. Okay. Now, our zeros occur only one time. And when the zeros occur one time, the graph just crosses quickly through those points, through those zeros. So at -1, it's going to cross quickly. And then it needs to reach a lowest point, and then it has to go back up in order to get to 5. And it will touch 5. It will cross x-axis here quickly, so it'll just keep going up. It's going to go like that. And then here, the graph will also cross the x-axis at 2, and it will just keep going down because there's no more x-intercept to touch on the right side of 2. So this is how the graph looks like. So now let's see if our graph is accurate. So here's the equation for w of x, and let's see how the graph looks like. And let us put this back, hide this back. And this is our graph in relation to the actual graph. So we hit the x-intercepts and the y-intercept. We have the same shape. We missed the lowest point and the highest point, and that's okay. We will not be able to find out where they are. We need calculus in order to find exactly where the lowest point and the highest point is, or the relative minimum and the relative maximum.